Hello students, welcome back to our channel. This is part 3 of chemistry class 8 chapter 3 elements, compounds and mixtures. In the previous part we have learnt about non-metals, noble gases, metalloids, compounds, etc. In this lesson, that is part 3, we are going to study about mixtures, their types of heterogeneous mixtures, the difference between mixtures and compounds, etc. So let us begin the chapter. Children, I told you it is an important chapter as well as an interesting chapter too. So we should be studying this chapter very consciously. So let's begin. So mixtures. Mixture is a material obtained by mechanically, means physically, mixing two or more substances, that is elements or compounds, in any proportion. For example, water is a compound. Take water and sodium chloride, which is an element, take that and mixed them in any proportion you want, physically, that is mechanically, not by chemically. Okay, so that mixture is, the obtained substance is called a mixture. Okay, children, remember that to obtain a pure substance we use chemical methods, but to obtain impure substance we use physical methods. We have some more examples. Let us read. So air is a mixture of nitrogen, oxygen, carbon dioxide, water vapor, etc. Smoke is a mixture of carbon particles and air. Gunpowder is a mixture of nitrate, sulfur and charcoal. Brass is a mixture of copper and zinc. Okay, now let us study about the types of mixtures. So types of mixtures are of two types, that is homogeneous mixtures and heterogeneous mixtures. So first we will study about homogeneous mixtures. Homogeneous mixtures, always remember the composition which is uniform throughout. Okay, suppose sugar water or sweet water is a homogeneous mixture. Why? Because the mixture throughout is uniform, whereas in salt water or in sand water, the sand will remain at the level below and the water will float at the upper level. Means the soil will remain below and the water will come above. Okay, so this composition is ununiform, or you can say not uniformly composed. Okay, so sand water is not uniformly composed throughout. Okay, so it is called heterogeneous mixture. Okay, so let us study about homogeneous mixture. A mixture in which the different constituents are mixed uniformly and has uniform composition throughout is called homogeneous mixture. I told you this. So we have some examples here, like brass is a homogeneous mixture of copper and zinc, and aqueous solution is a mixture of sodium chloride and water. Okay, so an aqueous solution of sodium chloride is a homogeneous mixture of sodium and water. Okay, look at these diagrams to understand better. Now what are called heterogeneous mixtures? I told you before, a mixture in which the different constituents are not mixed uniformly and does not have a uniform composition throughout is called heterogeneous mixtures. Okay, like sand in water. So see, for example, soil is a heterogeneous mixture, a mixture of some salt, sand and sulfur is a heterogeneous mixture. Okay, this is soil in water. See, the soil is at the below level whereas the water is in the upper level. Now this flowchart is really important, the types of heterogeneous mixtures. Okay, true solutions, colloidal solution and suspension. These three are really important, so we should be studying this very consciously. Okay, so first of all we will understand this true solution. Okay, let us study this. So we should be studying this very carefully, I told you. So see, this is the diagram I have shown you in this true solution. Okay, so this is a beaker and we have here this sky blue color is water, and this part means this violet color is NaCl, means sodium chloride. Okay, so the particles or the molecules of water is bigger than the particles or the molecules of NaCl, that is sodium chloride. So see, when the size of the solute particles, here solute particles is the NaCl, that is sodium chloride, the size of the solute particles are smaller than the water particles, that is the solvent particles. So solvent particles are big and the solute particles are small. Okay, so when it happens, the mixture mixes evenly with the solvent particle. So the sodium chloride, that is the solute particles, mixes evenly with the solvent particles, that is the sodium chloride mixes evenly with the water, okay, and is perceived as single component, okay. So such type of solution is called a true solution, okay, a true solution. Remember this. I hope the concept is clear. Now let us understand the concept of colloidal solution, okay. So here the full matter is the opposite of true solution, okay. Here the size of the solute particles, okay, here the size of the solute particles is greater than that of particles in the solution, okay. So which makes it to be perceived separately, but the solute particles became an integral part. Here solute particle, I am making you understand this, okay, integral part of the solution and cannot be filtered, okay. Let us see. So I have shown you a diagram of colloidal solution. So see, this is a beaker and we have milk and water added in this beaker. So this sky blue color is the water, that is the solvent, and this white color is the milk, that is the solute. So we studied that in this colloidal solution the solvent is smaller and the solute is bigger. The molecules of the solute is greater than the molecules of the solvent. So here what is happening, suppose this is the molecule, okay, I am showing you it. So look at this diagram. See, this is the milk particle, okay, and this is the water particle, okay. This sky blue color is the water particle and this white color is the milk particle. So we know that the solid particle is greater, so the milk is greater, and the water particles, that is the solvent, are smaller in size, okay. So see, in this case the water particle are getting attached with this big milk particle, okay, or molecule. So in this case the solute particle become an integral part of the solution, okay, means the milk here becomes the integral part, okay, the main part of the solution. I hope now the concept is clear. Also in this case the solution cannot be filtered, means you cannot filter water from milk, okay. So here in your book we have another example. See, milk is a complex mixture of calcium ions, sugar ions and other vitamins, okay. So here the milk particle is the solute, so the milk molecules are bigger than that of its solvent molecule, that is the calcium ion, sugars, okay. So we can't filter milk from sugar, and we can't filter it, okay. That means we can't filter calcium ions, sugar and other vitamins from milk, okay. I think now the concept is clear, okay. So let's move forward. Now suspension, okay. When the solute particles are big enough to perceive separately and can be filtered, leaving solute particles as a residue, such a solution is known as suspension, okay. Let it understand. So this concept is easy, I hope you can understand this. So see, this is suspension, okay. So this is, we are having a beaker and this is the soil particle and this is the water particle, okay. So water is the solute and the soil is the solvent, okay. The solvent particles or the solvent molecules are also big, and the solute molecules are also big, okay. So in this case this mixture mix separately, okay. For example, soil in water, then sand in water, salt in water, okay. In this case the solute and the solvent particles both are big molecules, so they separate, okay. I hope the concept is clear. Now what are the characteristics of a mixture? So the various characteristics of a mixture is, the constituents of a mixture may be present in any proportion by weight, okay. We learnt about this. Then there are no chemical bonds. I told you that chemical methods are used only to make pure substances and physical method is used to create what? Impure substances, okay. So chemical bonds between the constituents of a mixture, okay. Okay, the mixture can be homogeneous or heterogeneous. So in impure substance The mixture can be homogeneous or heterogeneous, but whereas in pure substances the mixture is only homogeneous. Why? Because in pure substances we use chemical method. To understand it better, please watch part 1 and part 2 lessons, okay, on this chapter. So see, there is no energy change during formation of a mixture, whereas in pure substances when we form compounds there is energy change during the formation, okay. Now, the constituents of a mixture can be separated by physical methods only. I told you this before. The mixture does not have a fixed melting and boiling point, okay? Because they are physically made or physically formed. So, see, preparation of a mixture and compound of iron and sulfur. Okay, so take 10 grams of iron powder in a pestle and pestle and mortar, and to it add 10 gram of sulfur. Okay, grind them well. Okay, so this is difference between their mixture and compound. Okay, so first let us see the difference in mixture. Okay, when grinded powder is taken into a watch glass we call it a mixture. See, the iron fillings and the sulfur are separated, they are not mixed. Whereas in their compound, when a mixture of iron and sulfur is heated, a black shiny compound, that is the iron fillings and the sulfide is formed. Okay, so a black color shiny compound is found, whereas here the iron fillings and the sulfur is separated. I hope it's clear. Again we have a difference. See, in mixture, when a magnet is brought near this mixture, the iron fillings cling to the magnet and sulfur remains in the watch glass. Okay. Whereas in the compound, when the magnet is brought near to it, the iron of the iron fillings, okay, the iron of the iron fillings, iron sulfide, you can say, remains unaffected. Why? Because the iron and the sulfide has formed a new substance, that is its compound, and it looks like black shiny substance. Okay, so that is why their compound remains unaffected. So here we have another example. So see, when hydrochloric acid is added, the mixture retains its individual properties, and iron of the mixture reacts to the form H2 gas, which burns with the blue flame. Okay, please read these equations. Okay, then when hydrochloric acid is added to the compound, okay, means which compound? With the iron sulfide, then it reacts as iron sulfide and liberate hydrogen sulfide gas with rotten egg smell. So also read this equation. I hope the concept is clear because diagrams are shown here. Okay, so when carbon disulfide, okay, when carbon disulfide is added, sulfur dissolves, leaving behind iron. Okay, see, this is carbon, this yellow color liquid is the carbon disulfide, whereas these are the dissolved iron fillings. Okay, and in their compound, when carbon disulfide is added to the compound, no visual change is observed, indicating the compound is insoluble. Okay, so see, this is the carbon disulfide and this is undissolved iron sulfide. Okay, so the carbon disulfide doesn't mix with this iron sulfide, but here the sulfur is mixing with the carbon disulfide, whereas the iron fillings remains undissolved. Okay, I hope the concept is clear. So now I hope this part is clear for you all. So in this part we have studied about mixtures, types of mixtures, what are the types of heterogeneous mixtures, difference between compounds and mixtures, etc. So in the next part, that is part 4, we are going to study about the nature of mixtures, separation of components of mixtures, and methods used for the separation of solid to solid mixtures, etc. So stay connected with the part 4. Till then, thank you students. Bye bye. Stay home, stay safe and study hard. Thank you so much.